So my topic today is to develop a dynamic digital twin at building and city levels. We use the West Cambridge site as an example. So there are a lot of new technologies came out, such as the digital twin and the Industry 4, and a lot of other new technologies, such as the UAV and the GIS. So that means the age of digital is approaching. So a lot of affects that over 90% of assets will be using over the next 25 years have already existed, and every minute there will be a lot of assets will be the existing assets. So the optimization of the utilization of existing assets will be our new challenges in the digital in the age of the digital. So how to build the connection between the building neighborhood city and with our humans, where an intelligent, convenient, virtual and sustainable channels will be our new task, no matter the researcher or the industry. So our projects, the CDBB digital twin projects, is try to develop a dynamic digital twin of the FM building. Is the Institute for Manufacturing Building in the West Cambridge site, and also our West Cambridge campus, and demonstrate impact and its facilities management and wider productivities and well-beings. We cooperate with many different industry partners such as Bentley, Topcon, Redbyte, and Qiuchen. So with the government reports about the data for public goods, so digital twin will be a solution for us in the futures. So how to design such a kind of digital twins, because a lot of research groups and the industry has their own definitions about digital twins, and what is the structure and architecture about of a digital twin in building and city levels. So firstly, we established a framework and architecture for the digital twins in building and city levels, based on the principles released by the CDBB report. So it has 5 layers. The first one is the sub-digital layers. It covers like buildings and roads and bridges and several other assets. And also the second one is the transmission layers. It will transform the data to the upper layers. And then is the digital model and the data complementary layer. We should choose a centralized digital model for the whole digital twins, such as the building information model or some other models. And then came to the data integration layer. This is the most important one, because we need to collect all the data and develop the functions, support for upper layers, such as how to make a smart decision making, support for further application layers, and then how our digital twin interact with our citizens. So with the guidelines of this framework, we established the demonstrator in West Cambridge campus. So our dynamic digital twins means we integrated a lot of data resources, such as the real-time sensor data and some asset management systems, and also a lot of existing data resources, such as building systems management and management systems and some space management systems. We will support for several applications. The first one is the as-is conditions, such as monitoring the performance of the specific spaces, and predict the future states, such as predict the electricity use, the water use, and some provide for better decision makings. So I will present our demonstrator in West Cambridge site in later. So we work with different industry partners, and we also work with the estate management of this university to support for data collection and also for the data resources collections. We mainly have 4 work packages. The first one is the 3-layer digital twin model generation. We have 3-layered digital model from the West Cambridge site to the building, and then to some specific places. In the West Cambridge site, we use the UAV to scan the whole West Cambridge site and generate the geometry model. For the second one, we develop building information model for the FM building. The third, we choose some specific spaces, such as planned rooms with complex assets, and also some specific lecture rooms as a case study. The second one is we deployed a lot of IoT sensors and make it successfully transmission to the upper layers, such as we installed over 50 sensors and around 200 assets has tagged in the FM building, including the temperature, humidity, motion detection, CO2 sensors. And we collect all the real-time sensor data and build a cloud-based platforms based on the Amazon Dynamic DB, and also cooperate with Redby develop a app could collect information from the human themselves. And this is a logic collected to how to transform the information and data to the upper layers about the sensors one, and also the information from the QR code. So the third work package is we promote a kind of international standards based on IFC in industry foundations classes, and classes all the different assets into two groups: the service-related assets and the monitoring control-related assets. Based on the IFC schema, we divided the two assets into two different groups, and to manage and control all the assets and to process different kind of data. So I also create a kind of applications. This application could support if the existing IFC files didn't have that kind of specific assets. This application could support the existing files to add new assets to existing IFC files. So our digital twin virtualization is integrated building management systems, asset management systems, and also space management systems, and also collect real-time information from the QR code and real-time sensor data. And we actually have two platforms. The first one is work with Bentley systems to support for potential products in the future about digital twin platforms. Another platform is developed by our research team, which is for research purpose. We will develop more interesting ideas and innovative ideas in the future. So the first one is the platform we cooperate with Bentley systems. This is the city level, and we could monitor the performance of specific places such as a platform, a playroom, and also some for evaluate the performance of some specific assets such as pump. This is the pump systems in our FM buildings. And another platform is the research platform developed by our research team. So firstly is the what's the Cambridge site. We can monitoring the as is and electricity, water consumptions, and also predict future electricity and water consumptions. And moreover, in the building level, could monitoring the as-is conditions of specific lecture rooms and theaters. And also basic on machine learning and decision-making trees to find the failure assets if some abnormality happens. So in the future, we have a lot of, not in the future, in the now, we have a lot of interesting applications such as augmented reality, and also the fault detections of the pumps, and also the maintenance schedule tools. So why we are doing this? Actually, we would like to produce a demonstrator for how to build a digital twin in building and city levels, and we actually would like to develop more research opportunities or industry opportunities for the digital twin area. So in the next 2 or 3 years, a lot of more interesting research ideas about digital twin will happen in our research group, and no matter in the city levels or national levels. Thanks a lot.